Hello all, this is a video demonstration on how you can connect to GeoSpock DB, run queries on GeoSpock DB via GeoSpock Discovery on a Jupyter notebook. So now I'm going to take you through some sample queries that you can do and run on GeoSpock DB and on Discovery. So the first one we're going to look into is getting 3 columns of all rows in a bounding box. Now, in this example, you may want to use this as part of looking at a particular area in a city, like a particular block, and seeing how much traffic is in that area, for example. Now, in this particular example, we are using the Singapore taxi availability dataset, and this is actually a dataset that anyone can access and download. You just need to go to the datagov.sg website, search taxi availability, and then you can have a look at it. We have got a sample of this data ingested into our Discovery deployment. So for this, we're going to select the latitude and longitude timestamp from GeoSpock default.sg taxi availability, where the longitude is between 2 points and latitude is between 2 points. So you're creating that square or box in that zone. We'll then run the query, and if you provide the variable of what you're setting the run query to be, you'll get a sample of that data as a data frame table output in Jupyter Notebooks. Okay, our query is done. I should also mention, whenever you run the queries as follows, you will get the following output. You'll get a start query time, a finish query time, the duration of the query, and then the number of rows that are returned as shown here. And then you get your sample data based off the fact that I've put the variable afterwards. So now, supposing if you're wanting to view this in a map, you can use something called Kepler GL. Now, in order to use this in Python notebooks, you need to make sure you've installed Kepler, set the appropriate settings in the Kepler object, and then you'll create your map by running this set of code. And there you go, there's our bounding box in a particular area of Singapore. Query number 2 is very similar to our first query, but this time we are filtering on timestamp. So we're interested, say, in a particular time range, either it's a particular day, or a particular month, or a particular year, or in some cases you might want to look at snippets of a day. So, for example, if you're wanting to look at rush hour peak times, whether that's has a massive effect on the data that you see, that data that you have, etc. So in this example, we're selecting 2 columns this time. We are selecting the longitude and the latitude from the same data set as before, Singapore taxi availability, where the timestamp is between timestamp, and I've set it as the 1st of January 2019, and it's only data within that on that day only, as my outside filter is the end of that day. So we then run this query, and again, you get a starting query time, and then once it's finished, you'll get the rest of the output. And there we go, it was a bit quicker query this time, only 600,000 rows returned and a query duration of 10 seconds. We now move on to query number 3, and it's actually combining both the bounding box and the time range filter as one query. The major difference, though, in this query is that we have changed the dataset. We are using a synthetically generated dataset with regards to vehicles moving around the Singapore city, and we are looking at, again, the same day, and then we're picking another bounding box as detailed in this section of the query here. So we're selecting just the timestamp this time from geospock.default.sg ERP2synthesis as ERP. But the timestamp is between the time range, and the longitude and latitude are between the box that we've defined. We'll then run this. This query may take a little bit longer than the other queries, primarily because of the fact that ERP is a much larger data set than what we had with taxi availability. Okay, there you go. As you can see, the query has returned an output, and as you can see, much longer in duration, primarily due to the fact that there are a lot more rows in this dataset, as I said previously. In the next video, I will show you how to run queries 4 and 5, which will enable you to retrieve the unique vehicle IDs within a bounding box and time range filter, and the percentage breakdowns by vehicle type.